Good morning, students. Today we will learn about Gauss's law. The Gauss law states that the total normal electric flux over a closed surface is 1 by epsilon times the total charge enclosed within the surface. So before going to learn the Gauss's law, we should learn what is electric flux. What is electric flux? Electric flux is the number of lines of force, the number of electric lines of force which are passing through the surface in a direction perpendicular to the surface. So just like shown in this figure, okay, here we have a rectangular surface. Okay, the yellow color lines are electric lines of force. So the number of lines of force passing through this area are called electric flux. Okay, it is represented by phi is equal to E dot ds. For the total entire surface, the total phi is equal to integral of surface integral of E dot ds, that equal to E dot ds means we know the dot product of vectors. So from that, E dot ds is equal to E ds cos theta, where theta is the angle between the lines of force and the normal to the outward normal to the surface, which means let the surface is just like a rectangular surface. We have the outward normal is in this direction, okay. Therefore the outward normal direction is parallel to the direction of the electric lines of force here. Hence the angle between the outward normal to the surface and the electric lines of force is 0. So in this case theta is 0, which means cos 0 means 1. So we remain with the integral of E dot eds. Okay. Similarly, in this surface, outward normal is in the upward direction. Okay, and the electric lines of force direction is in this direction. The angle between them, angle between these two lines are 90 degrees. Hence, we have the theta is equal to 90 degrees. So depending upon the surface which we have chosen, the theta depends, and hence the value changes in accordingly. Okay. Now we will take sign convention for the flux. Whenever it is entered towards a surface, okay, whenever the force, the lines of force points towards a surface, the flux is taken as negative. Whenever the electric lines of force is outward from this surface, the flux is taken as positive. Okay, this is the sign convention whenever we use flux to the entire surface. Now we will prove this Gauss law in two cases. The first case is whenever the charge is taken inside the surface, and the second one is whenever the charge is taken outside the surface. Now we consider the first case when the charge is within the surface. Okay. Now let us consider any arbitrary shaped surface. Okay, in which we have a plus q charge here at point O, and to calculate the Gauss's law for this surface, we have to take a very infinitesimal surface through which how much flux is going out. We should calculate the how much electric flux is going out from that surface, and then we integrate for the entire surface. Then we will get the total normal electric flux through the entire surface. Now let us have a positive charge here at point O. Now consider a point here at point P. The distance between the charge and the point P is r. Now consider a very infinitesimal area of ds around that charge, around that point. Consider a very infinitesimal area of area ds around that point. Now the outward normal from this surface is, suppose let it be in this direction. Okay, the electric field direction is in this direction. Let theta be the angle between these two lines, to electric field and outward normal. Theta be the angle between these two lines. Now the electric flux through the infinitesimal area of area ds is given by, the electric flux is d phi e. D phi e is equal to E dot ds. E dot ds means E ds cos theta. It is a dot product between two vectors. Hence E dot ds is equal to E ds cos theta. Okay. From Coulomb's law, we know that E is equal to 1 by 4 pi epsilon naught Q by R square. This is where E is the electric field intensity. Now that E is equal to 1 by 4 pi epsilon naught Q by R square. From equation 1 and 2, we get d phi E. This d phi E is equal to 1 by Q by 4 pi epsilon naught R square. Here for substitution of value for E here. Okay. Therefore Q by 4 pi epsilon naught R square and ds cos theta. That equal to Q by 4 pi epsilon naught to ds cos theta by R square. Ds cos theta by R square. This is equation number 3. Here ds cos theta by R square represents the solid angle subtended by the surface at point O. Okay. So this is represented with d omega. D omega is the solid angle subtended by the surface at a point O. So from the equation 3 we have d phi E. D phi E is equal to Q by 4 pi epsilon naught and ds cos theta by R square means d omega. So d phi E is equal to Q by 4 pi epsilon naught into d omega. So this is the amount of flux through this small surface area of area ds, isn't it? Hence the total flux, for to determine the total flux we should integrate the equation, whatever equation we arrived here for d phi E. Okay. Therefore the total flux through the entire surface is represented with d phi E. Sorry, phi E. The total flux through the entire surface phi E is equal to integration of Q by epsilon naught d omega. Here Q and 4 pi epsilon naught are constants, hence we can take it out from the integral. Take it from the integral where we remain with the integral d omega, Q by epsilon naught, Q by 4 pi epsilon naught integral d omega, where integral d omega is the solid angle subtended by the whole surface at point O. What we said in our earlier slide, here d omega is the solid angle subtended by this area only at point O. Now integral of d omega means the solid angle subtended by the entire surface at the point O. Okay. Hence the integral d omega is the solid angle subtended by the whole surface at point O, and the value of this